This time we will present the Chapter 6, Ethernet and the spanning tree. The topology is like this. We will use the simulator to present. The first, we will display the interface status. So the command is display interface G009. So you will see the port state status is up and up, which means the port itself is working properly. Um, the second one, we will present how to change the interface speed and duplex. By default, the negotiation is auto. So the command is disable the ne negotiation auto. So you can set up speed 100. By default is 1000. Duplex is full duplex. So display current. You can see under the interface 009, the speed is 100. Auto negotiate is disabled. Now we will change it back to auto negotiate. Now we will start to create a ether trunk, which means this interface 009 and 0010, they both configure as a trunk, but you can aggregate these two interfaces. So from both sides, you can see the just the one logical interface, and the traffic will be load balanced on these two links. The command is you first create ether channel trunk. You can give a number here. Let's see, 1. And next, you go to the physical interface, and basically you say this physical interface is a membership. It's a member of the ether trunk 1. So you go to 10. You use the same command. So which means is this ether trunk 1 has two members, 009 and 0010. So let's display interface ether trunk 1. So you can see uh, the physical interface is up, and now we will configure on the other switch. So we create a ether trunk. We assign the number 1, and we go to physical interface 009, and assign the ether trunk number. We go to interface 0010 and do the same thing. So now we should see the ether channel trunk is up and up, and you can see the number of ports in the channel. There are two, and the ports of up, I mean the number of up ports in trunk. There are two, and you can see the two numbers. The second lab in this chapter is the spanning tree protocol configuration. Spanning tree protocol (STP) um, is a network protocol that ensures loop-free topology for any bridged uh, Ethernet network. The basic function of spanning tree protocol (STP) is to prevent bridge loops and the broadcast. The spanning tree is standardized as the IEEE 802.1d. How that works is basically the whole network will select a root bridge, and from each other switch they will calculate the cost to the root bridge, and they will leave the path with the shortest cost as the active link. Um, for sure, it will disable all the other paths. In this case, so the traffic, so the tree looks like the top is the root bridge, and the branch is the active link to each switch. That's basically how it works. Um, in this topology, um, to see if this switch is the root bridge, um, so basically most likely this link will be blocked. So from this bridge, and this link may be blocked. Depends on the configuration. So the tree looks like that's the root bridge. You have one active link to this switch, another link to this switch, and this one is the active link to this switch. Or you can block this one, and so the tree is like this. Now we have a fourth switch in our topology. By default, let's see by default who is the root. So how to check the root is you display STP. Um, you can see the like that's the bridge, that's the switch ID, that's the priority, and the switch MAC address. So you can compare this one and the root. So if the root uh, bridge ID is same as the switch ID, which means this switch is the root. So this one are different. So let's see. S3, S3 you see here, the bridge ID uh, is this one, and the root is the same. So by default, S3 is the root. So let's back to the topology. So here is the root. So all these other three switch will calculate the best path, which has the lowest cost to the root. That's why the most important thing in the spanning tree design is to decide who is the root. So generally speaking, uh, like this network, um, this is our core. It's kind of core network, and this two switches are the access switch. So generally speaking, we should use either of these as the root switch. So let's change S1 as the uh, root switch. The command is spanning tree root primary. And we also set up S2 as the STP um, root secondary. So now let's display the STP again. Now you see when we set up the switch as the root primary, you see um, this priority has been changed from, by default, the priority for each switch is 32768. So, but when you set up this switch as the spanning tree root primary root, it automatically change the priority as the 0. So in the whole network, the smallest bridge ID will become the root switch. So because the bridge ID has two parts, the first part is the priority, the second part is the MAC address. So if you don't have this config, so in the network by default, since this priority by default they are same on all the switch, right? So the switch which has the smallest MAC address number will become the root switch. That's why in our case S3 became the root. Um, so when we configure this one, we basically set up this spanning tree, uh, this bridge priority as 0. So they compare this priority first. So this one, let's see what's the secondary. So the secondary, if you set up this spanning tree root secondary command, um, so the priority will be changed to 4096 from the default um, 32768. So now we have here's our primary root. That's our secondary root, which means if everything is good, this one is our root. If for some reason this switch stopped working, this one became the root. The We will not use the access switch as the root. The next command, the next important command is display spanning tree protocol brief. This one can tell you for each interface the state, and so the role of each for each interface um, is like is configured like this. This DSI is stand for designate, and let's see this one. What's the rule here? Display SCP brief. So you see here. So another thing to see who is the root is on the root switch. All the ports are in the uh, designate rule, which means here all these three interface. That's why is we create the Ethernet trunk 1. So these two physical interfaces has been bundled together. So from the root, you have designated port here, here, here. So only the root, all the port are the designated root. This one is our another switch. So from this switch, the port here and here are designated. But this interface, the rule is root, which means last the interface connect to the root or on the path to the root. To see like this, S3. Let's say this as S4. Um, STP brief. Okay, so this interface is the root, which means this interface connect to the root, and this one is alternate, means less the backup link to the root. But this port will not take any traffic in this case. You see this triangle here? That's a loop. So the only thing you can break the root in this case is block this interface. So the traffic will go this way. So if you send traffic from here to here, the traffic will go here and go to here. So let's check S3. So S3 is very similar to S4. So this interface is the root, and this one is the alternate. Again, this one will not take a traffic. So if you send traffic from here to here, you go this way. If you want to see the status on each interface, you can run this command: display STP interface under the interface number. So in this case, we are checking this interface here. So this interface, you can see that's the bridge, that's the root, and there's a lot of parameters here you can check. So when you run this command, um, you can show a lot of parameters. That's the port 25. It's called the 25. It's not really the physical port. It's just a logical port. It's the Ether trunk 1. So this port, that's the status. It's the forwarding, which means this port is send traffic. Uh, and the row is designated uh, port. This port priority, that's the port priority, not the switch priority. So um, that's the port, that's the bridge port. So the bridge ID, that's the port ID. Port ID is the port priority plus the port number. Also, you can see the port spanning tree mode is MSTP. So now we have three different spanning tree protocols. Um, STP, um, RSTP is rapid STP, and MSTP is multiple instance STP. We will get more detail later. That's timers, like a hello is 2 seconds. Um, and the BPDO is another very important the package used to share the bridge and the port information um, in the network. We will get more detail later as well. Next, we will shut down those interfaces on S1. Let's see who became the root. Shut. So basically, we isolate S1. So we shut down all the interface here. So let's see S2, definitely STP. You can see now that's the bridge ID, that's the root. You can see um, S2 became the root. So on S3, when you see STP, STP brief. So you can see you have only one port, which is this one. Connect to the root. This one is the same thing. We will not run the command, but it's the same. So basically, this one used to send traffic this way. Since this interface was down, so it will use the alternate port to send the traffic to the new route. So now let's enable all the ports. Let's see if the S1 became the root switch again. So I'm shut. STP. Now you can see S1 became the root again because it has the lowest priority. Now you can see on S2 you can see the root switch is switch 1. This one is the switch to bridge ID. Another command that we use the most is they call the edge port. Edge port is the port connect to the host, not connect to the switch, to see if we have an interface on the S1. To see interface 001. If this port connected to a server or a computer or even a router, we can set up this port as the edge port. So the command is stp edge port enable, um, which means um, this port will not, should not receive any BPDU, which is the package used to share the spanning tree information, uh, because the host and the server shouldn't create any loop. Another thing is the port come up, uh, this port should be directly put into the forwarding uh, state, so it can send the traffic right away. Um, this, but should be very careful to set up this command. So if you set up a port as the edge, but if the port is connected to another switch, which means this port is supposed to be involved in the spanning tree calculation, it may block this port. So just be careful. So in these two labs, we learn how to set up the root, the spanning tree root switch, uh, the primary and also the secondary. And also we learn how to set up the uh, edge port. That's the two important, the most important thing in the spanning tree topology. We will get more detail like BPDU and how they decided which one is the root and how we set up the path to the root. We will get this detail in maybe in another lab.